Hello everyone, this is a very basic video regarding the trigonometry portion of your syllabus for the MYP or the O levels. As you know, trigonometry is a word that can be broken down into three portions. Trigonometry. Tri means three, gono is from the word polygons, and polygons are closed shapes made with straight lines. And metry is related to measurements. So when you are measuring or dealing with the measurements of three-sided polygon, basically a three-sided polygon is simply a triangle. In trigonometry, you tend to transform or translate all your working into solving triangles. By solving triangles, you mean to work with the three angles that a triangle involve and the three sides. It's not necessary that you deal with all the three sides or all the three angles. Um, Depending on the information, you can see what you need to apply, which mathematical tool that you need to apply in a given information. So we can chalk down different types of information and hence the different tools that are most beneficial or efficient in that. So first of all, it's three sides involved. When you have three sides involved and no angle, out of these three sides, two are known and the third is unknown. In that case, your simple way out is the Pythagoras rule. The Pythagoras rule states that the sum of the two smaller sides in this case will be A and B, the ones which are connected to the 90 degrees. These are the smaller sides. Their squares added is equal to the biggest side. And I'm going to label the biggest side as C. So the sum of two small squares is equal to a bigger square. And it's quite clear that C is going to be the biggest side of this triangle because 90 is the biggest angle that can be drawn here. If one angle is 90, then no other angle can be more than 90 because the total sum is 180. So both of these have to be less than 90 in order to make it a sum of 180. Having said that, we also label this C as the hypotenuse. So two sides known and the third unknown, our way out is Pythagoras rule. And continuing further, if we have angles and sides both involved, I'll put it here, angles and sides involved, then our way out is the trigonometric ratios. I think all of you are quite clear with the sine, cosine, and tangent ratios. In higher discussion, higher level discussion, we can see uh, what are tangents, cosine, and sine. But right now, these are trigonometric ratios you might want to see on your calculator as well. The sine, cosine, and tan. Tangent, written in short as sin, cos, and tan. Now, for writing the statements for the trigonometric ratios, you always need an angle of reference. For example, if I have this triangle, angle theta, then the side opposite to this angle theta, it will be the opposite side as the word suggests, and side which is next to it or adjacent to it is the adjacent. The opposite side and the adjacent side. And this one is the unanimous choice, hypotenuse. So for any right angle triangle, we will take an angle of reference, and with respect to that angle, we will decide what are our opposite, what are our adjacent, and hypotenuse is always there. And then once you have identified this angle, the trigonometric ratios are simply learned in a most efficient way, most common way, called the so, ka, and toa. It means sine is sine of the angle, any angle, let's say in this case, theta, it's opposite over hypotenuse. Cos of the angle, theta, is adjacent over hypotenuse, and tan of the angle is opposite over adjacent. You can see from here that if there is no hypotenuse involved, you can write it like this: no hypotenuse involved, then you have only one choice. Then your only choice is the tangent ratio. And if hypotenuse is involved, it means tangent is out of question. Right. So let's take a look at this question. It says find the exact value of x. If you consider the part A is we do know two sides and we are required to find the third side. And you can see here, if two sides are known and third side is unknown, before I forget it, this is all this discussion that we have done, it's right angled triangle. I should have mentioned it at the very start. All this discussion for Pythagoras rule or trigonometric ratios is done in a right angled triangle. So two sides known and third side unknown, it's all good to apply the Pythagoras rule. And this side, which is opposite to the 90, is the hypotenuse. The best way is to write the statement of the Pythagoras rule first. So you write x square equals to 2 square plus 3 square. If I have to find the value of x, I need to get rid of this square, and I'll have to take square root of both sides in that case. We got x equals to 4 plus 9, which is square root of 13. As it says exact value, so exact value means keep your square root as it is. All right, as I mentioned that when you're involving angles like cos theta or sine theta or tan theta, when you're involving angles and sides, then we use the trigonometric ratios. And for trigonometric ratios, sine, cos, tan, for you to decide which ratio is it or just write the definition, you need an angle of reference. So according to this angle theta, this side is the opposite and this too is the adjacent. Hence, for B1, if we were to write cos of theta is adjacent over hypotenuse. In this case, adjacent is 2 and hypotenuse is x, which is root of 13, which we have already worked out in the previous part. Similarly, we'll do it for sine and tan. So sine of theta is opposite is 3, and hypotenuse is root of 13. And lastly, tangent of theta is opposite over a. Here the opposite is 3 and adjacent is 2. So it's 3 over 2. Also notable is that you can always write, if you look at the definition of tangent, tangent of theta is opposite over adjacent. What if I divide each of the numerators and denominators by the hypotenuse? Hypotenuse is just one length. So if I divide both the numerator and denominator by hypotenuse, opposite over h is simply sine. You'll write sine of theta. And adjacent over h is cos. This is another important result that you may have to use for higher studies especially, but it's good that you know at this level. Tangent theta is simply sine theta over cos theta, or in terms of the length, it's opposite over adjacent. So that's the very basics of trigonometry in right angle triangle. We're using Pythagoras rule in a certain situation. Similarly, you're using the trigonometric ratios. Knowing the type of information that you have. Thank you for watching.